Good morning, everyone. Hope you are doing well. So today we are going to start our new lesson on data analytics. So first, let's understand what is data. So what is data? So raw facts. Data is raw and unprocessed facts that does not bear a meaning on its own, right? So data is raw facts that does not bear a meaning, right? So to make data valuable or to make data useful, we need to process them. We need to process them. After processing, data will become informations, right? Using that information, we can make decisions, right? So you may have heard a term as data is the new oil. Data is the new oil. What does that mean, right? So in this modern digital world, data is the most valuable asset, right? Right? That's why we call data is the new oil, right? Oil, the crude oil, crude oil was very valuable thing. Like when the industrial revolution happened, the demand for the crude oil got increasingly higher, right? Likewise, that demand is there in this modern digital era to the data, right? It's like actually it's even more valuable. Like as example, think about Facebook, right? How Facebook make money? How Facebook make money? So Facebook make money by showing its users targeted advertisements, right? How they show target advertisements? When I log into Facebook, let's say I want, I today I want to purchase a tree. So when I see that kind of a beauty product, I will like it, right? Then that data will get saved in the Facebook databases, and the the algorithm will analyze that data, and the next time when I log in, it will show me targeted advertisements, right? So can we show targeted advertisements in televisions? No, right? Right? So in television, we show advertisement for the mass audience, right? So that's the power of data. So the data is the most important asset in the modern digital era, right? So what is data analysis then? So data analysis refers to the process of inspecting, cleaning, and transforming and modeling data to discover useful information. Data analysis means like it's about analyzing or inspecting, cleaning, transforming, and modeling data to derive useful informations, right? Like that's what we do in our normal life as well, right? So let's say, as an example, I want to go to gym. I want to go to the gym to exercise. So, to make that decision, so uh, like like to like I need to decide whether I want to go to the gym at the early morning or at the evening. So to make that decision, I will consider, okay, today morning I have a class, today afternoon also I have a class. So I will analyze these things and decide, okay, morning I will not be able to go to the class. Okay, so morning I will not be able to go to the gym. So I will consider going in the evening, right? So that's what data analysis is about. So for the businesses also, it's really, really important. right? That's why data analysis is become the most demanding job in the today's world, right? So to organization to make decisions, they have to go through very large amount of data. We have to analyze that data and make insight. So that the organizations are able to make decisions, right? Okay. So data science. Data science is the science about data. Data science is the science about data. It's a scientific discipline like physics. Like physics is about the nature, right? Physics, we try to understand nature like that. Data science is about extracting meaningful insights from data, the study of data to extract meaningful insights. So it's a discipline, it's a multidisciplinary approach that combines principles from fields such as mathematics, statistics, artificial intelligence, and computer science. The data scientist or the data analyst is the job role or the professional who analyze large data sets and apply data science techniques to extract actionable insights, right? To extract actionable insights. Okay. Data analytics is one of the more highly demanding jobs in the IT industry today, right? So, and there are five key essential skills that a data analyst should have. As a data analyst, you should have these five traits. First thing is curiosity. A data analyst must have a natural curiosity to explore data and understand the story data tells. To understand the story data tells, you have to be curious. Curiosity will drive you to ask questions, then seek patterns and identify insights, right? Second thing is understanding context. That means what? Data does not exist in a vacuum, right? Data does not exist on its own. It always it's a part of a context, right? It's a part of a context. As an example, right? So if you get a customer satisfaction data, it will be related to like some sort of a business, right? So within the business context, we have the customer satisfaction data. So to become a good data analyst, the second skill you need to have is understanding of that context, the context of that data, right? Right. If you are working with customer satisfaction data of a retail business, you need to have some sort of idea about context, such as products, uh, customer like economics, the retail industry economics. Likewise, you need to have that idea about the context, right? Then the third skill is technical proficiency. Technical proficiency means data analysis. Data analysis use different tools and technologies like various tools like Excel, SQL, then programming languages like Python, R. Likewise, you need to be have that proficiency, that technical proficiency. So, right, data design refers to structuring and organizing data in a way that is easy to analyze, store, and retrieve. It's about organizing data, right? So this will include designing databases, creating data models, and understanding how different data sets relate to each other. So a good analyst need to ensure that data is organized efficiently and appropriately to support analysis, right? Data strategies means understanding how to use data to support business goals and decision making. So a data analyst must be able to think strategically to ensure that data collection, storage, and analysis align with that objective. The entire data analysis process need to be aligned with that business objective. So also this includes prioritizing which data to collect and ensuring we are following data governance practices in the organization. So as a data analyst, what are the five uh, skills you should have? First thing is curiosity, then understanding the context, then having a technical mindset and data design and the data strategy. So as a data analyst, we follow a problem-oriented approach. So what does that mean? A problem-oriented approach. We focus on the problem first. So our focus is on understanding the specific problem first. So after understanding the problem, then we use data to analyze and solve it. That we call as a problem-oriented approach, right? So we are focusing on understanding the problem first, then use data analysis to solve that problem. So that will ensure our solution is aligned with the problem. So ensures relevance and targeted solution, right? So ensure the relevance of the solution. Data lifecycle means the stages that data goes through from its initial collections to its eventual archival or deletion, right? It's like humans, right? As humans, we also come to this world as a small child, then we go to school, then we go to the university, then we go to a job, getting married, having kids, then we get old, and eventually we are dying, right? So the data is like the same, right? It also has a life cycle from its birth to its eventual archival or deletion. The first step is data generation. So data generation. So data generation means the process of gathering data from various sources. So this can include data from sensors, surveys, social media, likewise, right? Then the second step is data storage. Data storage. Once the data is collected, it needs to be stored. We can store them in a structured or unstructured format, right? And we can store them in a database, data lake, in a cloud storage. Then we have the data cleaning, right? Data cleaning means the raw data is really in a perfect state, right? So we can't make decisions from raw data. So we need to clean data, right? So data cleaning involves removing inconsistencies, removing errors, removing duplicates, and removing irrelevant information. So after data cleaning, we can standardize data, right? So then we have the data integration. Sometimes we need to uh, uh, use multiple sources, data from multiple sources. So we need to combine or integrate data from multiple data sets, create a unified data set. right? Then we have the data analysis. After that, we can do the data analysis. After the data cleaning, we do the data analysis. So this includes is examining and analyzing the data to extract useful insights, patterns, and trends. So in this step, we use statistical analysis and algorithms and other analysis techniques to analyze data, right? Then we have the data visualization. Data visualization, right? So the analyzed results need to represent visually, right? So then only we can understand that data, right? So after doing the visual representation, everybody can understand the story the data tells, right? So we use here we use tools like Power BI to do the data visualization. Then we have the data reporting. So it's about summarizing and uh, summarizing and presenting the findings. Then based on that findings, we can make decisions, data-driven decisions. After that, the data will be archived. So, because sometimes it may like after the decisions taken, the data is not be relevant. No, we will not be using that data, right? Sometimes we can feel like, so this data will be valuable in the future, right? So rather than deletion, we will archive that data. So after archiving, like let's say after some time, we can go to the deletion of the data, right? So that for the disposal of the data, right? So we have to do this disposal in a very like what do you say, in a very like in a responsible way. Like we can like sometimes we are working with uh, sometimes we are working with sensitive data of clients, right? So we can't like we can't allow unauthorized persons to access that data, right? So we have to dispose them in a responsible way, right? So that's the data life cycle from its generation to its disposal, right? From we generate data, then we store it, then we clean it, then we analyze it, then based on that analyzing, we make data visualization. Then based on that, we make decisions. After that, the data will be archived. Okay, then after it will get deleted. Right? Right. So based on the type, we can divide data into mainly two types: quantitative and qualitative. Quantitative and qualitative data. Qualitative data means the data that we can't measure in numbers, right? As an example, what is your gender? It's male or female, right? Then what is your like what is your eye color, or what is your education level? So we can't measure these data in numbers, right? So these data are called qualitative data, right? So qualitative data also can be divided into nominal and ordinal, as nominal and ordinal, right? Nominal means we can name or name or label that data, but we can't rank or order them. We can't rank or order them. As an example, let's say gender. male or female, right? We can uh, uh, label the data as male and female, but can we rank them based on the gender? No, right? We like, let's say in a for a subject, let's say mathematics, we can rank students by their mathematics marks, but can we rank someone based on his gender, right? No, we can't rank them, right? So it's either male or female. There is no such thing as 1, 2, 3, 4, right? So that's what that means. The data, nominal data means it can be named or labeled, but can't rank, right? Then we have the ordinal data, right? So we can or rank or order, we can rank them, but the differences between values, differences between values is meaningless. There's no meaning for the differences, right? Like, let's say as an example, education level. Let's say as an example, education level. So let's say high school, bachelor's, and master's, right? Then we have the quantitative data. Quantitative means the type of data is measurable. The data is measurable, and we can express in numbers, right? Right? Like, let's say if I ask you how many students are in this class, right? You can answer me from a number, right? So that we call as quantitative data. So it also has two types: discrete data and continuous data. So as the name suggests, discrete data is the data consists of whole numbers. So uh, this discrete, right? It consists of whole numbers, and it has countable values, and it cannot be broken down further. So examples are number of students in a class, right? So it's 40. It can't be 40.2, right? No, it has to be a whole number, right? Then we have the continuous data, right? So continuous data means the data that can be taken any value within a range. Let's say 50 to 60 or 60 to 2, right? Data that can take any value within a range, and it's measurable, right? As an example, let's say height of a student, height of a student, right? So let's say it's 150.2. So can we exactly say it's 150? No, right? We can't exactly measure a person's height. Like whenever the scale gets like it will be depending on our scale, right? So if we measure it like from a meter rule, we can get a rough idea, right? So it's 150, right? If we measure his height from a uh, device with better uh, better sensitivity, so it can be like 150, like 150.234 we can measure it for like this much of a decimal points, right? So that kind of data, right? The data we can be measurable, but we can't represent them as a whole number, right? So these kind of data is considered as continuous data, right? Then we can also we categorize data as quantitative and qualitative. Is it measurable, right? Is it based on the attribute as is it measurable? So if it is measurable, it's quantitative. If we can't measure it, it's qualitative, right? Right. Like that. Here we define data as structured, unstructured, and semi-structured, right? So, so unstructured data means raw data like text, PDF, images, video. We have not done any process on that data. That's unstructured data. Then we have the semi-structured data. They have some sort of a structure, but not fully structured. As an example, we can say a JSON file. In a JSON file, we have a key and a value, right? So it has some structure, but not fully structured. So this data we call as semi-structured data. Then we have the structured data. Structured data is, uh, so as an example, we can say a data inside a relational database. So in a relational database, we have tables, right? Tables are interrelated with the primary key and the foreign key. So inside a relational database, what we have is a structured data, right? Right. So these are processed data, right? So based on that, we can categorize data into three types as unstructured data, semi-structured data, and as structured data, right? So so as the data science, data analysis, we need to have 5 skills, right? The first thing is curiosity, then understand the context, then technical proficiency, and data design and data strategy. The third skill is having the technical uh, efficient or the technical skills. So for data analysis, we use different tools, right? As Microsoft Excel, SQL, Python, R, for data visualization like Power BI, right? We use different tools, right? So let's try to understand how we can analyze a data set using Microsoft Microsoft Excel, right? Microsoft Excel, right? So let's download the simple data set and try to analyze it, right? Okay. First, go to this website, kegel.com. So here they provide us uh, freely available data sets, right? So go to kegel.com and you can see we have different data sets. So uh, you can download a data set. So I will download this. So you will be asking to log in. So I will log in with my Gmail. Okay, you can download. So download the data set as a zip file. Extract it. Okay. Okay. So this is our data set. So it's about farm farming, farming related data set, right? Right. So it's feel like it's already processed. So I will go with this data set. So it's the data set about sales of items, uh, sales of items uh, within some time. So let's try to analyze this data set. So we will try to understand what is the best selling product, what has generated the most revenue, right? So who is the best performing manager? So let's try to uh, understand these things from this data set, right? So first thing is what? First thing is uh, so first thing is cleaning data, right? First thing is cleaning data. So you can see here in the manager, there are like it's not properly structured and there are like unwanted spaces. Like here you can see Tom and here you can see Tom and Jackson. You can see Tom and Jackson, there is an unwanted space, right? So first thing is, I want to fix these errors, right? So in Excel, we have functions for that, right? You can see, you know that in Excel, when we want to get the summation of two numbers, we have sum function, right? Average, AVG function, average function, right? Likewise, we can use uh, Excel functions to fix these errors. So, uh, so first I will make this a table. Okay, first I will make a table. Then I will use string. I want to trim the values of a manager. So from start, so I want to start from I3 cell and go to the end of that manager end of the table. So I can press Control Shift down key, right? Okay, now after that I got the uh, uh, I can fix the like that spacing error, right? Then I will delete this manager column. So uh, then I can see here in quantity. Can the quantity be a numeric? Can the quantity be a decimal value? No, right? Like, can I sell uh, 569.67 burgers? No, right? It has to be a whole number. So I will fix that also. I can use round up, round up. Here I want to round up the quantity to 0 digits. Right? Right. Uh, right. So I get the whole numbers. Right. Uh, right. Then I will. Then I can remove this quantity. So I will rename this as quantity. Okay. So now I will remove the check whether there is any duplicates. So if there are any duplicates, I will remove them. So okay. So now I have checked for any um, uh, check for errors, missing values, and for duplicates. Right? I have fixed the errors, remove the missing values, and uh, remove the duplicates. So I have now clean my data set. Now I have cleaned my data set. Right? Then I can go to data analysis. Then I can go to data analysis. Right? So, right. So here I'm using statistics to uh, statistical techniques to analyze data, right? So we know statistic is a mathematical discipline that concerns with collection, organizing, analyzing, and uh, analyzing data, right? Right? We learn it in our uh, A levels and O levels, right? Statistics is that subject, right? Statistics is a branch of mathematics that deals with collection, organizing, and analyzing numeric data to solve real-world problems, right? It is a branch of mathematics that deals with collecting, organizing, and analyzing data. There are mainly two types of statistics. There are two types of statistics: descriptive and inferential. Descriptive statistics and inferential statistics. We have descriptive and inferential statistics. In statistical analysis, we have mainly two analyses: descriptive and inferential statistics. In descriptive analysis, we we summarize or describe main features of the of the data. Summarize or describe main features of the data. So we have the data. So we will describe the main features of the data. Like we have the data set. So we will calculate mean, median, mode, range, standard deviation, those things, right? Summarize and describe main features of the data, right? Then we have the inferential statistics, right? So here, this is about making predictions based on a sample. Right? So what that means, right? Making prediction based on a sample, right? So here in our example, we directly downloaded a data set from Kaggle, right? We downloaded data set from Kaggle. But in actual scenario, what will happen? Let's say we are doing a research, right? So our research topic is the like understanding the usage of understanding the usage of CI/CD or DevOps practices in Sri Lankan IT industry. Right? Right? So we are doing a research to understand the usage of DevOps practices, in Sri Lankan IT industry. Right? You can see. So what is our population? Population means the entire population. What is our population? From where we collect data. So it's about IT industry in Sri Lanka. It's IT industry in Sri Lanka. So to understand the usage of DevOps practices, we need to collect data from IT, from every IT company in Sri Lanka, right? So can we do that? No, right? We can't do that because our population is very large, right? So, so, so we have to take a sample of that population, a sample that sufficiently represent that population, sufficiently represent that entire population. So we take a sample, right? Let's say we take a sample of 100 IT companies. Then we collect data from that 100 IT companies. We collect data, let's say from a questionnaire. Collect data from a questionnaire. So we create let's say Google like a question sheet and distribute it to the 100 companies. From that we collect data, right? From that we come to the point of having the data set, right? So that's inferential statistics, right? So it's about making predictions based on a sample, making prediction of based on a sample, right? It includes hypothesis testing, uh, then confidence intervals and correlation, regression. Likewise, we do different uh, testings, right? Inferential statistics, statistical techniques, right? Basically, right? It's about making predictions based on a sample. So it includes probability distribution, hypothesis testing, regression analysis, condition intervals, likewise. So in descriptive analysis, we have the measure of central tendency, mean, mode, median, measure of variability, range, variance, standard deviation, likewise. Then a geographic representation, histograms, both plot, pie charts. So we will learn these things. So in so to analyze data, we use statistics. In the statistics, we have descriptive statistics and inferential statistics, right? Inferential statistics is about summarizing and describing the data. Inferential statistics is about making predictions based on a sample. So you need to have that idea. So let's go back again to our data set. All right. So now we have cleaned this data set. Now let's try to analyze. Right. So we will do the descriptive analysis. That means I want to create uh, calculate the average, mean, mode, median of this data. Right. Okay, so first calculate the average of price, average of price. So you can use Control Shift down arrow to select all the rows. Right? Okay. So the average price is 7.341. Okay. So in here in Excel, actually there is a we do not need to do this manually. So we can there is a tool set for that. So, so here go to file and options, uh, add ins, and there is a tool pack as analysis tool pack. So uh, select it and click go, then tick analysis tool pack and click OK. Right. Uh, Now go to data and you can see data analysis. So now I want to do a descriptive statistics. Click OK. So I will do a descriptive statistics on the price, right? And I want the summary statistics and output options as I will show the output in the let's say in L column, and select the column, select the cell, and click OK. Right. Now I get all the descriptive statistics like mean, standard error, median, mode, standard deviation, sample variance, kurtosis, skewness, range, minimum, maximum, sum, count, everything. So these are the uh, descriptive statistics of price. So let's do the same thing for quantity as well. So we have calculated, like we have done the descriptive analysis for price and quantity. But here, like there can be outliers. Like, outlier means a data point that significantly deviate from the rest of the data sets or the data points from the rest of the data points in the data set. So we need to remove outliers as well, right? After calculating this, there still can be outliers. So we need to remove outliers as well. So we can do that by go to here under insert, insert statistical charts. Here, click box and whisker. Right. So here you can see we have uh, outliers. Basically, this uh, top and bottom lines telling us the uh, minimum and the maximum values. And this box represent first and the third. X represents the average. So then these are the outliers. These are the outliers, the values that are significantly deviate uh, from the rest of the data points. So, so we need to remove these things as well. Let's check from where these outliers coming from. So, so we can do that by like for the x-axis, we will add uh, the manager's names and see from where these outliers are coming from. So right click, then click, then select horizontal category axis labels, click edit, and the name as manager. So, so we can see the outliers are coming from this. So, so we need to check these values and remove them. Right. So now I want to analyze this data set and uh, get an idea about what is the best selling product. Then what is the total revenue? I want to get the revenue breakdown by the payment and method. So, right. So, after fixing errors, removing duplicates, and removing missing values, and treating missing values, and removing outliers. Now I will go to this data. I will do the data analysis to find these things. What is the best selling product? What is the total revenue? And get the revenue breakdown by the payment method. So first I will calculate the revenue. So here revenue can be calculated as the price multiplied by the quantity. So price multiplied by the quantity. So that will show the sales of that product. So this calculate it like that. So I got the sales by each product for each product by multiplying price by the sold quantity. So to find the best selling product and the total revenue and the revenue breakdown by the payment method, I can use a pivot table. So here in insert, click pivot table, right? Select the table and use a new worksheet and click OK, right? So here I want to get the product and values is the uh, revenue, sorry, quantity. So so I can get the best selling product by quantity. So the highest selling product is beverages. As you can see, it has sold 35,666, right? So I can here name it as product and this as quantity, right? Then I will sort it as show value, sort it. I will sort it as smallest, so largest to smallest. So beverages is the most selling product, and slides and other are the least selling product. So let's then at the let's check the revenue from each item. Right. So I can add revenue as a new column. So you can see from beverage, even though the beverages are the most selling item, it's not the most like profitable item. It's burgers, right? Burgers make the largest, like burgers make the largest uh, income, right? But then let's calculate the total revenue. So here select revenue. So we will give the total revenue. Our total revenue is 812,135.13 30.30. So that is our total revenue. So I want to get the revenue breakdown by the payment method. So I select the payment method, and the sum of the revenue. So I will so summarize values by sorry, show values as uh, show values as percentage of grand total, right? Okay, you can see from the grand total, 29.49% was made by cash, 49.722 made by credit card, and 20.7979 was made by gift cards, right? So you can understand we had uh, we had this data set, right? Which does not, like, it's just a data set. First, we clean it by removing errors, missing values, and removing outliers. Then we did some statistical analysis. We we did a descriptive analysis, statistical analysis, and we get insights, right? What is the best selling product? What is the total revenue? And the we got the revenue breakdown by the payment method, right? So that is data analysis, right? Right? We simply did it using the Excel sheet, right? Then we need to learn how we can do advanced data analysis with R, Python, and we can do the data visualization with Power BI and like so. And there are three approaches for data analytics: descriptive, predictive, and prescriptive. Descriptive means that analysis will tell us what happened, right? It's about past, it's about historical data, right? So it uses descriptive statistics and historical data that will tell us what happened. So how is performing, what happened, right? Examples, as an example, we can see doing descriptive analytics. We can see our sales dropped by 10% last quarter. So we can compare the uh, the data with the previous one and come to a conclusion that sales dropped by 10% last quarter. So it's about what happened. Then we have the predictive analytics. Predictive analytics means it will tell what will happen, what will happen, right? So we will use statistical models like inferential statistics, regression, then algorithms to do the predictive analysis, right? So it will tell if this trend continues, sales will drop 15% next quarter. Likewise, it will do a prediction. So we will use algorithms, statistical modeling like regression to do those things. Then we have prescriptive analysis. Prescriptive analysis means it will tell what you should do. What you should do. So, uh, so, uh, so it will use optimization, simulation, and decision models to do the predictive analysis. We will use these things. And example, to avoid the drop, it will suggest to increase digital ads by 20%. So from our next weeks, we will be focusing on these three: descriptive, predictive, and prescriptive analytics. Okay, right. Right. So then we need to have an idea about SQL as well. So we learn about SQL in our relational database subject as well. So SQL stands for structured query language. Structured query language. So it is the language we use to retrieve and insert data into a relational database, right? We learned about DDL, DML commands. Hope you can remember. So, so in a relational database, what we have? In a relational database, we have tables, right? So we have the structured data organized in tables, right? So basically, if you can remember, the relational databases for operational purposes. A relational database for a part of a system, right? Say, e-commerce management system. There was a part, the database is a part of the system we use to store data, right? And there are data we can't uh, find that relationships there. We can't exactly find that relationship, right? So that we call as big data, like a large amount of data getting created in a very rapid rate. So that we call as big data. We can't store big data in a relational database. So big data is for these analytical purposes. So using big data, we do this analysis, descriptive, predictive, prescriptive, likewise, we do this analysis, right? It's for decision making. Relational databases were for operational purposes, and the, the big data and that analysis is for like for the analyzing purposes, right? So we will we will go about big data in the next week as well. So there is 5 characteristics. 5 is volume, velocity, veracity, variety, and validity, right? So 5 characteristics of big data. So we will learn these things, and today I will just recap your memory on SQL as well, right? So I will open my SQL Server Management Studio. So connect with the database server. Okay, open a new query. Right. So let's create a database like employee DB. So there will be 3 employees. There will be 2 entities like employee and the manager, and the 3 entities. There will be 3 entities like employee, manager, and the department. So the each employee will have a name and the ID and the department, and manager also will have a ID, name, and the department, and department will have a ID and a uh, ID and the department name. So, uh, so the department ID will come as a foreign key to employee and the management manager table. Okay. So first let's create the database. Create database company DB. Then I will use that database company DB. Then I will create uh, create table department so department will have a department ID. It will be a integer and it is the primary key. then department name, sir, Raja. So then I will create another table, create table, uh, employee, employee ID is the primary key. Then employee name, Vacha with 30 characters. Then he will have a department ID, department ID, and it is the foreign key. Foreign key is department ID. It will reference to the department tables department ID. And then I will create uh, create table manager. Hmm. Manager will have a manager ID, will be an integer, and it is the primary key. Then he will have a name, manager name. It's a Vacha with 30. Then department ID, it's an integer, it is the first. So I have created uh, these three, this database and the three tables. So these are DDL commands. You can remember data definitions language commands. So create, uh, uh, create and create, drop, alter, truncate. Those things are DDL commands. Then so, uh, right. Right. Then I will insert data to this these three tables. So I'm using DML commands, like in DML commands, data manipulation commands. You can remember insert, update, delete. That those things are DML commands, data manipulation language commands. So I have added values to these three tables. Then I'm using queries, right? Uh, Queries to retrieve data. So first I will retrieve everything from employee table. right? So I got the everything in the employee table. Then I can use where clause to uh, get data from based on a condition. So I will say select all so all from employees where department ID is 1. So I want employee to get the employees where their department ID is 1. Into 1. Right? Then I want to select all from employee. Then use order by clause. Order by employee name ascending. Right? So I get the employees in a ascending order. Right? Uh, then I want to get uh, uh, then I want to get for each department how many employees are there, right? So I can use group by uh, closure here to group. So select department ID, count employee ID as number of employees from employee group by department ID. Then there is SQL functions like count. So I want to get total employees from employee table. So I can use count function. Count function. You can remember there were functions like min, max, average, right? Those kind of functions, SQL functions, right? Select count. So there are total 5 employees in this employee table, right? And then I want to get the employee name and the manager name, right? So employee and the manager is in 2 different tables. So to get these both data, I have to join these tables, right? You can remember there were left join, uh, right join, and the inner join, right? So full join likewise. Uh, so so here I'm saying select e dot employee name, m dot manager name from employee, that means E, employee table. To that table, join manager table, which represented by M on uh, the condition E on the department ID. E dot department ID equals to M dot department ID, right? So I'm joining 2 tables, right? Right. So I can get the employee name and his manager name, right? So that's what we learned in SQL commands, like DDL, DML, and EQL commands, right? Right. So so basically we learn about clauses, functions, and joins, right? So what I want to do is I want you to do a homework. Uh, Go to this site, Solo Learn, and under courses, go to programming languages and beginner. You can do the introduction to SQL commands to refresh your memory on SQL, and you can do the Python course as well, right? So because we are using Python for data analysis, so you can do those things. So thank you for joining today. Then let's stop for today. So thank you very much.